Welcome to Samba Samba. Enjoy the video.
You start by stabilizing the environment and calibrating instruments so measurements reflect the resonator, not the room. Connect a broadband source and place a sensitive probe at expected coupling points. Sweep broadly to capture peaks. Once done, compare to your baseline ambient spectrum to exclude common noise lines. Make sure to note reference peaks and equipment response. This prevents false positives. From here, target obvious resonant bumps for higher resolution scans and mark candidate frequencies for focused testing. Now you refine each candidate with narrow, high-resolution sweeps to reveal true resonance shapes and Q factors. Longer dwell reduces noise and shows stability. While sweeping, capture phase response to distinguish standing modes from transmission artifacts, and vary probe position or input polarization to map modal coupling. Once you see consistent amplitude and phase behavior across repeats, log frequency, bandwidth, and spatial pattern, make sure to label modes by symmetry and coupling strength so you can prioritize which resonators to isolate or tune next. Finish by verifying each identified resonator is reproducible. Repeat measurements, tweak temperature or mounting slightly, and watch for expected shifts in frequency or Q. Then isolate the element, add damping or mechanical decoupling, and confirm the targeted peak diminishes. This proves causality. Once verified, document frequency, Q, mode shape, and measurement conditions so others can reproduce it. If things go wrong, check grounding and probe contact first. These common issues mimic resonances and are easily fixed.
Thanks for watching. Consider subscribing if we helped you.